In Kubernetes, understanding pod statuses is crucial because they tell you what's going on with your pods. So in this video, we'll dissect each of these statuses, and we are going to understand what triggers them and how we can troubleshoot effectively. So let's dive in. All right, so let's work our way backwards. This is what a healthy and happy pod looks like. And if your application pod is ready, it should be responding to requests. We can check the container logs by pressing L in canines or using simple kubectl commands. But a pod goes through many different phases before it gets to this ready state. And any of these phases can fail due to various reasons. So next, I'll show you each of these phases. And for each phase, we'll look at a couple of different scenarios where things can go wrong. When a pod is created, the very first phase it enters is the pending state. It means that a pod is waiting to be assigned to a node in the cluster. And at times, you'll see the pods getting stuck in the pending state for a long time. And there could be a few reasons for that. Here, we have a pod that's been stuck in a pending state. So first, we need to describe the pod. And here we can see the details about our pod. But what we are really interested in is the events, which we can find at the bottom. And in this case, none of my existing nodes have enough capacity left to accommodate this pod. Now, if you have a cluster autoscaler configured, it will automatically create a new node. And once the new node is ready, it will schedule the pod onto that node. But it can take a few minutes before the pod is scheduled. Also remember that since the pod is not even scheduled on any node at this moment, there are no containers running. So there is no point checking any container logs. Let's look at another example. Here we have another pod that's stuck in pending state. So again, let's describe the pod and look at the events. This one is complaining about a missing persistent volume. It could have been a missing config map or a secret as well. So through this example, I wanted to show you that sometimes your pod might have a dependency like a persistent volume or a config map or a secret. And if that dependency is not ready or missing for some reason, then also the pod will be stuck in pending state. The next phase is container creating. Once the pod has been scheduled on a node, Kubernetes will try to pull the image, or specifically it's the kubelet that pulls the image and creates the container. So we can describe the pod and check the events again. And here we'll see the message that it's pulling the image. There are a couple of factors that dictate how long you'll see pods in this state. The first one is image size. The larger the image, it's going to take more time to pull the image. The second reason is that by default, kubelet pulls images serially. What does that mean? It means that it sends only one image pull request at a time. Other image pull requests have to wait until the one being processed is complete. So for instance, if you have 10 new pods on a specific node, and each pod is using a totally different image, it's only going to pull one image at a time. And image pull time is one of the major reasons for slow pod startup times. So is there any way to improve this? One solution is to configure kubelet to allow using parallel image pulls, as we can see here in the Kubernetes docs. Now, there are some caveats in enabling this feature, which we won't go into the detail in this video, but I want you to be aware of this configuration. So things can go wrong when kubelet is trying to pull the image. And that's when you'll see the image pull error status on the pod. So describe the pod and look at the events again. In this case, it's trying to pull an image that does not exist in the repository. Or sometimes the image tag is not present. And these are the most common scenarios when you'll see this error. But at times, it could also be related to some networking issues. For example, if you're pulling images from a public registry like Docker Hub, it might be rate limiting the IP address. Or if you're trying to pull an image from a private registry, your pod may not have the right credentials to authenticate to that registry. So always describe the pod and look for the events to get the reason for these errors. Once the image is pulled, Kubelet will try to start all the containers in the pod. And if something goes wrong while trying to run the container, you're going to see this crash loop backoff status. There are many reasons this can happen, so let's look at a couple of them. First, as always, describe the pod and look at the events. In this case, we're not seeing any useful information in the events. So let's scroll up a little bit. And here in the state, we can see that the container was terminated due to an out-of-memory issue. So at this point, you'll have to check how much memory limit you have set on your containers. And you may need to adjust that limit. Remember that sometimes containers and applications use more resources during startup. So you need to take that into consideration if you are setting resource limits on your pods, which you should. If you're using canines, it will show you crash loop backoff and kill in the status, but you may not see that if you're using kubectl commands. Here I have another pod that's crashing. So let's describe this pod as well. And again, in the events, we don't see a lot of information. And if we scroll up, in the state, it doesn't show any reason either. It just shows that there is an error. So in this scenario, we need to check the container logs. A lot of the times, you'll see the crash loop backoff because your application is crashing due to some dependency like a database, a cache, or some other tool or application which is not deployed, or maybe that dependency is not yet ready. Another common reason is that your probes that you have defined are failing and the endpoint the probe is using is not returning a successful response. So at that point, you'll need to debug your application code to understand what's going on. Alright guys, that's it for this video. I hope it helped you to understand all these different statuses of a pod. And although it's very difficult to cover each and every scenario where things can go wrong, as a rule of thumb, anytime you're seeing issues with your pods, always describe them and look for events. And if containers were created, check for the container logs. But for now, I appreciate you all and I'll see you next time.